thank you very much for this opportunity. So I'm really glad to be here and to share some of our experiences with you. I have to make a little bit apologize. So I'm just starting to get a sore throat. So I hope I can carry through the presentation. And I just want to jump into to give you some experience and what has worked for us and where we came from. So this is a number of programs we have been participating in. So we on board on the Boeing 787. So we do the power management system in the plane. It might be interesting for you. So this plane has 1.5 megawatts of electrical energy on board. So it's really huge. This is approximately the amount of 3 little villages. And you need to distribute the power within the plane to the right places. Otherwise, you are in real trouble. So, and I don't mean the coffee machine by this. It's a full fly-by-wire plane, and so it's really essential to have electricity distributed to the right places. And we are running a network with 60 processing and communication nodes within the plane that takes care of distributing the power. So it's the communication backbone of the power management system, and we do cabin pressure control. Another program is the predecessor of the space shuttle, the NASA Orion program. To get the next generation of space flight going again, we provide a backbone communication within this system based on our technology again. So we are quite proud. So we had initial contacts with NASA on research level like 15 years ago, and so it's this time horizon that it really takes to get on board, and by, I think in a month or so, we will have first flight of the capsule. So you see the time constants on some of these programs. It's really takes some time, and we are proud to be on board of this program because NASA is clearly a US governmental organization, and they usually buy in the US and not in mid-sized Austrian, Vienna-based companies. So you need really to differentiate there. This is Audi. We have some program with software on board on this car to manage some safety critical connectivity between the braking and other functions. And you know the Austrians like to ski, so snow groomers are clearly some of the target focus that you need to have in Austria. We provide the electronic controls of this. So this gives you some idea. When we were initially starting 1998 with 3 employees based on some European funded research programs. These are the 2 notable programs with some of the customers. And this was really a success story for us. So these were research programs that were done at Technical University of Vienna. So I was involved with Bosch, Robert Bosch company at these programs. And so really for this type of X-by-wire functionality, safety critical communication, there was really industry momentum building up. And this was sparking the idea to fund a company, which we did in 1998. So in 1997, we took some half a year for business planning. So we wrote a business plan. So my important statement, I'm saying this at the end as well. The business plan, it's really for you and for the investors, because you need to write up how you want to do if you want to start up company. So you really need to consider how you want to do it, what's the market, what's the product, and if you're not convinced by your own that you can do it, then don't go to an investor to ask them for money. So this is what we are doing for in 1997. We set some internal benchmark that we said we want to raise $1 million of money to start the company, otherwise we won't do it because we feel it's too little money to sustain it long enough and don't get in trouble. This was our internal benchmark. We met that benchmark for us, and this was really when we kicked off by the turn of the year and started in 1998 with 3 people, the company. So since then, this is what the performance of the last year. So, you know, 2008 was a crisis year, so we went pretty flat and had some loss at that time. This was the big crisis situation. It was important at that time for us not to terminate any contracts with employees, because they are the key asset of a high-tech company. It's really, at a high-tech company, it's the people are the assets and the patents. This is really what you have within the company and what you really need to keep, because if you get rid of the people, then maybe you are having problem the next time to get top talent, because they feel, well, this is maybe a shaky company and you shouldn't work there. So we are now going towards 55 million euro of revenues. We are roughly 350 employees in the company worldwide. We have external resources, roughly contracted people, 150, so we are about 500 people in the company, and the majority of those people, 2/3 are engineers. So we are working in safe networking, deterministic networking, and safe controls. This is the essence of what we do. And so you met Rob Siegel. We have a business case running at Stanford. So Stanford, in their class on entrepreneurship, there's a case study on TTTech, and we've set the internal benchmark to achieve $100 million next year. So I think more or less we are going to manage this, given the exchange rate of the dollar that we have fixed for this case, and so we give a yearly update on this benchmark. So this gives you some idea on presence. So we have I would say some European footprint in Vienna, in Ingolstadt, obviously for some automotive activities. Bresanone, Italy, there we do some of the snow groomer business. Then we have development sites in Bucharest, in Brno. We are now going to Serbia in order to get enough talent. So this is really one of the critical issues in Europe, that it's really hard to get enough talented engineers, and it's really necessary to spread out to get really top talent, because usually you don't get it on a single location. But clearly this makes only sense if you have a certain size. If you're small, you need to start very focused with enough people. But at some point you really need to branch out. And then clearly Asia is a topic for us. On the one hand side, Japan for some of the Japanese customers, China, clearly Shanghai, some activities in Korea. And then in North America, we are currently building up our office in the Bay Area for some of the Silicon Valley customers. And we have an office in the vicinity of Boston for the East Coast customers that we are having. So it's quite typically, I think, in high tech, you need to have a global footprint, because you have global customers. We don't have Austrian customers, almost none at all. Okay, so I've spent already a few words on the Dreamliner. This is one of the programs, the power management system. So this gives you some detail. So all the blue units, they are networked with a system that we have developed. I was mentioning this already. So this is other programs like the Bombardier C series. In this program we are doing fly-by-wire based on time-triggered communications. So it's really, we are responsible for the connectivity between the pilot, who is giving commands to a flight control computer, and the flight control computer calculates a safe flight envelope and then gives the commands to the flaps. Quite interesting here, there are detailed aspects. For example, you need to be able to withstand a lightning stroke in the wings. So you go fully digital into the wing, where you actuate the hydraulics. And if the lightning strikes into the wing, then you're allowed clearly during the lightning strike that you are able to give commands. But after the lightning has been gone, you need to be completely in a safe position that all the actuation is going on. So this is, and this is clearly something that's, what we have been seeing is that usually not enough that you have some core technology. In our case, it was really reliable networking, deterministic networking, but you really need to have certain adjacent know-hows and adjacent capabilities in order to provide a meaningful solution to the customer. Because if we would go to the customer and say, okay, we have deterministic communication and you need to do the physical layer, you need to do the data transmission, and you need to do the scheduling on the network, then the customers will say, ooh, it's nice, but simply the entrance barrier for the customer is too high. So this is quite usual. If you're starting out a company, you really need to target towards a niche. And usually you need to start in a vertical fashion. That means you need for a particular segment or particular niche, you need to provide something like a more or less complete solution. Going out and providing some overarching technology that's used from servers to embedded or something like that, this is usually not going to happen, because it's simply too complex for the people to introduce this if you don't give them specific help to start in a particular segment. Okay, that's the NASA program. For example, on the NASA program, it's quite funny. So what was the compelling reason so that they came to us? In essence, it was the fact that they had planned dual Ethernet networks. One was the safety critical network and the other one was the convenience or data network. And so they had a gateway between the networks so that the standard network has no influence on the critical network, on the safety critical network. And we could show them that we could do everything on a single network, which means less components, less weight, and every kilogram, every gram that you need to lift up to space is very, very expensive. So every weight that you can save is really bringing a substantial advantage to those missions. And we could show there at a variety of levels that we have partitioning at the network level, so that you have a network, you have, in that case, it's triple redundant gigabit network, and we can show partitioning that the critical traffic can never be disturbed by the other traffic, even though it's going on the same physical cable. And for example, there, one of the important things was that we had formal proven algorithms that took care of clock synchronization, of some of the partitioning properties, of startup, so that we really not only have a solution, but we had all the theoretical framework there that really shows them the soundness of the solution in all the corner cases of a distributed algorithm. And this is some work that we have done jointly with SRI on the formal method side with John Rushby. We had a visiting researcher there who are doing this jointly. So it's really, you see there, so theory is really making an impact here for a complete solution that we could offer then to NASA. So this is another large program that we are currently doing for wind power. So again, the differentiation here is wind power. This is clearly, especially the offshore side of wind power, it's high investment. So the next generation of wind power, of wind turbines there, they will have a rotor diameter of 164 meters. That's, you could imagine, if you know St. Stephen's Cathedral, then the nacelle, so the body, the hub would sit on top of St. Stephen's Cathedral, and then you have the blades. Each of them, the 3 blades, would be 80 meters of size. And if you have such a monster in the sea, then it really needs to pay off, and it pays only off if it's generating energy. And if you have a failure of the electronics, and then roughly 30% of all failures are, based on statistics, are taking place on the electronic side of those wind turbines. If you can have this on offshore and you have wind gusts or high wind or high waves, then you can't get there, because if it's gusty wind, you can't fly in with a helicopter. If it's high waves, you can't go there by boat. And if this monster is standing for 2 weeks and not producing energy, then you are losing money, and this is bad. So it was obvious that what they were looking for was a technology that's quite similar to what you have in aerospace, so you go for redundant, high available solutions. So you put in redundant electronics because the cost of the electronics to replicate things is minor in comparison to having the wind turbine sitting still for 2 weeks. So this was really what we've been doing here. So we are providing, based on our deterministic time-triggered Ethernet, we provide switching solutions, a redundant network, and safety controller boards, which you see on top, which are providing the safety IOs to control the blades and control all the actuation. Yeah, this is a snow groomer. So snow groomers are, at least the big ones, they are high-tech machines, they are drive-by-wire. So we provide some of the controls there, some of the networking inside. It's driven with a joystick. And there we provide the full controllers for this machine. So you see the functions that they have, like adaptive suspension control. They have a MMI. So we provide these displays and visualization units. Yeah, that's the snow groomers. So these are the car programs. We do a time-triggered networking on. We started with the Audi A8, and now this safety software. So we have some safety software there that bubbled down to the current Golf model. So all of Volkswagen Group and some others, they are using safety software for safe data transmission in the cars. This is one of the activities that we were doing. This is electrical Volvo. We did a safety controller there. Again, here, for example, it's about safety. You know, with electric propulsion, you have full torque at 0 speed, so you can they push full even if they're standing still, unlike a gasoline engine where you have the clutch and limited torque at low RPM. And so you need to make sure if you have some electronic failures in your inverter, in your controls, that you make sure that you don't hit a pedestrian or somebody passing by the car because due to an unintended acceleration. So this is a big program we are currently working on that's on the way towards autonomous driving. So we are working there with Audi, who is a partner. Here you see the controls for this. So it's not only that Google is working on this, so many of the car companies are working on this. And this is really a program that is geared towards production in the near future. So in a very small number of years, you will have this on the market. And what this really is, this is somehow, it's almost an embedded supercomputer. So this is on a single board. It's the processing power, it's a number of multi-core SoCs that are working there. So we have like 16 CPUs working, we have 192 graphic processing units working there, we have gigabits of memories, we have 10 gig of video data streaming coming in, we have gigabit Ethernet to coordinate all the parallel processing activities. And this was the A sample that was demonstrated publicly early this year at the Consumer Electronics Show. So the first functions that are going to come will be automated parking, so that you leave the car, you press on your mobile phone or on your key, and the car enters the parking lot or enters a parking space. If it's a tight parking space, you come there, you can pull out the car, that you have more space to enter the car and then get in. And the other one will be automated driving congested traffic. So you have congested traffic, and then it's really autonomously driving there up to a certain speed, and you can do different things, and you don't need to watch the car anymore doing that. So this is something that's will be, and there are several other functions, but that's the starting point, and this will go gradually step by step. And so we are pretty proud. So this board was developed by us on the hardware side. We did all the middleware, all the communication, all the platform, where all this functionality is hosted towards autonomous driving, and we do the safety concept. So this is really, I would say, currently in the automotive area, one or the hottest topic, how to achieve automated driving in terms of performance, in terms of safety. And I think there are certain fundamental challenges here on the research side, and especially on the aspect of object detection and sensor fusion. Because if you want to do this in a safe fashion, then this is a very tricky task, because usually what state of the art is today is if you go for some of these certification approaches, what automotive is doing, what aerospace is doing, what some of the industries is doing. So you have on the one hand side the design assurance guidelines, so certain processes like things like reviews, traceability, requirements, coverage, all the processual issues. And then you have clearly the functional side, where you have control algorithms, where you look into stability criteria or other criteria that make sure that the functional side is fit for the purpose. And this is something that's extremely challenging on object detection and image recognition, because there's a lot of probabilistic stuff involved here. So we have redundancy here. There's laser scanners, there's radar, there is camera-based system, there's ultrasonic, which serve different purposes. And so you can do sensor fusion from different sources. But clearly the question is, if you rely in terms of safety on this functionality, how can you establish safety criteria? And this is something where up till now I haven't seen anything that's really, I would say, a very solid scientific foundation for this. So they do millions of kilometers of testing to get statistical evidence, but this is clearly something that has certain limitations. So this is one of the research challenges that I see in this area. So this gives you, this is a short video. So I hope it's working. Is it audible to you?
Yes. In 2009, Audi was the first manufacturer to test piloted driving in the desert. Far away from civilization, an Audi TTS drove over the Bonneville salt flats and reached a world speed record for piloted driving of 130 miles per hour. Driving autonomously, the TTS mastered the legendary Pikes Peak hill climb in 2010. The Audi completed the 12-mile climb with 156 bends in around 27 minutes. The top speed was about 45 miles per hour. Using GPS, the Audi was able to determine its position down to 2 centimeters. In 2013, Audi became the first car manufacturer in the world to receive a license from the Nevada Department of Motor Vehicles to test autonomous vehicles. Audi presented its vision of piloted driving, demonstrating it in traffic congestion and when parking. In the future, thanks to piloted driving from Audi, the car can easily be maneuvered into the garage or a tight parking space from the outside using the remote control key or a smartphone. Now it's time for series production. When in 2013 Audi was still at the preliminary development stage, the computing equipment needed filled the car's entire luggage compartment. Now this technology is as small as a laptop and goes by the name of ZFAS. All functions, one unit. The processors on the ZFAS board achieve a total computing output equivalent to the complete electronic architecture of a current Audi A4. All functions are controlled by ZFAS to make piloted driving possible. Up to 12 ultrasonic sensors scan the close environment of the vehicle. The front radar detects objects up to a distance of 250 meters ahead of the car. The rear radar sensors monitor the traffic behind. The top view cameras work together with the ultrasonic sensors, for example, when the car parks piloted. For the first time, a laser scanner delivers highly accurate data up to a distance of 80 meters. The front camera, with a wide angle, recognizes the lane markings, as well as pedestrians and objects. By combining these sensors, the ZFAS enables the piloted driving. The vehicle always knows exactly what is happening around it. Piloted driving. The future is now. Audi is continuing to extend its lead and is already using series production technology.
So clearly this is more marketing style, but it gives some of the ideas what they are trying to do and what type of sensing is really involved. And so, as I've said, this is really a major market, and in the McKinsey report on global megatrends, it's one of the 5 megatrends, autonomous driving, so it's really very important because many people are sitting in the car, and much of the time can be used with, let's say, for different purpose than just sitting behind in a congested traffic situation and moving up some meters, then stopping and doing this again. Another aspect is clearly safety aspect. So human drivers are clearly good, but it's not the best thing for humans to constantly monitor something if something goes wrong and then react. This is something a computer can do much better. So there is clearly a lot of fatalities that could be removed if more automated driving or more safety features are brought to the car. But this is clearly only a starting point, because what's usually happening there is that automotive has some type of a snowplow effect, because they bring typically technology to a low-cost point. And if the automotive guy bringing low-cost laser, low-cost radar, low-cost processing power that is embedded and rugged, then several other applications will clearly follow. And this will enable things like human-robot collaboration. So all the things where you need to make sure that the interaction between a machine and a human is taking place, then you need sensing, sensor fusion, to make sure what the machine is doing, what the humans are doing, so that the collaboration is really happening there. So I think this is really very important. Please.
I would think that as major legal obstacles in this plan, is Audi concerned about that, or what do you know about it?
Well, that's true. The Vienna Convention has been amended already to make this possible, changes. There are some other legal obstacles besides the Vienna Convention, but this is a thing that all the car manufacturers are working jointly on.
But it would mean that if there's a major accident, then maybe the car manufacturing are at fault, and would they take the risk of selling their technology if that's the case?
That's currently what they think, yeah. And so the way this is approached is, in essence, that internally there's a lot of data logging, so that you have like a black box recording functionality, so that you can establish based on this what was at fault. Because the driver can clearly override what the car is doing, and what the car manufacturers really want to make sure that this doesn't become a thing that they are always blamed that the car did something that was wrong. And based on this black box recording technology, they think they can negotiate. So of course, there might be cases when the car or the car manufacturer is at fault, and there might be cases clearly when the driver is at fault. But this is clearly bringing a new dimension to this, because so far it was always the assumption the driver is at fault because mechanics and all this stuff is very, very reliable.
Does Audi have any estimates of when this could actually be on the market?
There are several announcements, not only from Audi, for 2016. Okay, so this shows a little bit what we are doing at the company. We are active in these 4 market segments: aerospace, automotive, special purpose off-highway vehicles, and then industrial. And we have certain technologies that we apply there in general and that we work on. This is clearly deterministic networking based on Ethernet. It's safety controls, so building blocks to build a safety controller, and it's certain integration technologies to put the things together, to do scheduling, to do integration work in an efficient fashion that we apply here. This is really the business model. So we spend a lot of money in these core technologies, and then we apply it in certain market segments. That's the way how we work. Another strong trend currently, or there's a lot of a buzzword like the Internet of Things. So there's, I would say, a little bit of fluff behind that, but some stuff is clearly real, that many things of the physical world are going to be connected to the internet. And there are 2 reasons for doing this, especially in an industrial context. One aspect is big data, so you do data sensing, concentration of data, and then do optimization, preventive maintenance, provide certain services. So this is clearly one trend, and the other trend is what could be termed control over IP. So that you do the control no longer embedded in a deeply embedded fashion, but that you do a more centralized control and exercise the control over the network to be more flexible. And these are clearly trends that are going to prevail, and again, it's one of the real big trends that are going there. In that respect, we are working together with Cisco, because Cisco, they own roughly 50% of all internet networking switching. And we work with them on 2 aspects. One is standardization to get deterministic time-triggered traffic into the IEEE standard for Ethernet. And the second aspect is clearly we are working with them to bring some of our switching and deterministic communication know-how to their industrial line of switches. And so this is really one approach of us in terms of partnering to bring this technology to a much broader market than we as a small company could access. So, and if you look into what's happening in telephony and data communication, so all the special purpose telecoms communication schemes, they have been completely eradicated and dominated. It's now clearly Ethernet. Ethernet, voice over IP, all the data is going over Ethernet. And I think that the same trend is going to happen on the industrial control side. I think Ethernet will in a couple of years dominate all these proprietary protocols, so there will be a big change, and I think the standardization towards deterministic or time-triggered Ethernet that's now taking place in the IEEE will really in a couple of years bring a strong change here in the market, really a big shift, and this is something we are clearly interested in and want to grab some market share. Yeah. So as I've said, so it's clearly in an industrial context, you need, on top of Ethernet, you need to address safety features. This is something that needs to be done, how to do that in a systematic fashion. It's the convergence between the embedded side of things, the control side of things, and the IT side of things that needs to be addressed. And it's virtualization of control, so that you move the control out of the machine to some type of data center or local data center type, so where you can easily access the controller, upgrade software, just the same thing like you have in today's modern data centers, where you have virtualizations, hypervisors, where you can stop partitions, boot the operating system, run new applications. So I think the same trend that we are having on the cloud side is going to come in terms of a private cloud to factory automation. And so what we try, being active in these different business areas, what we try is really to use the leverage between the areas. So for example, in aerospace, there's a lot of safety heritage that we are using. In automotive, it's clearly low cost that we are using. And so we try to use these different industries really to move our technology forward. This is, for example, we have licensed this technology for next generation car. So BMW will introduce in their next generation 7 series a complete Ethernet backbone in the car. Again, this is a sign that shows that Ethernet is going to be a dominant solution even in the car. Yeah, this is sometimes some details on the technical solution. So what we do here, you could consider it's like some sort of a virtualization on the network. So you can partition the network in virtual LANs and then assign certain real-time and timing properties on these virtual LANs, which can be guaranteed, where you can introduce redundancy. And so you have standard Ethernet traffic, you can get streaming data on the network, or you have phase control time trigger data. And this can be really scheduled, assigned across routes, and so you get really a very strong partitioning argument and safety argument for the network that works clearly very nicely together with the hypervisor or virtualized approach. So what you have in terms of virtualization on the execution side, the same approach is really here on the networking side, and it works very nicely hand in hand. So I don't go into this. This is some of the standardization work that's going on within the IEEE to introduce time-triggered deterministic communication. So I think it's probably taking another 1 to 2 years until this standard is finalized, and this will give full time-triggered traffic as one of the within the IEEE 802 QBV standard. Okay, so this was a little bit giving you some ideas what we were doing as a company, and now I want to share some of the struggles in starting up a company and some of the things that I found were some learnings for me, at least in the process that we had now over the more than 15 years. So first aspect is clearly in high tech you need to have patents, because patents is somehow the currency where you can deal. You are not going to have, unless you are very lucky and have some fortune inherited or a lot of money. So patents is the thing that you can create as a researcher, you should create, and this is something you can leverage in order to build a company. This is securing your, I think it's only two ways, either you patent or you have certain technology that you keep secret. But keeping technology secret is much harder than doing patenting. Because somehow you need to protect, because you need to have something unique in order to do a startup. A next thing that's clearly extremely helpful is that you should build some demonstration of your technology. So you should do this, because if you go out to investors, if you want to raise money and you have a demonstrator, it's an order of magnitude more valuable if you can show this that it's really working, even if it's not perfect, but still you can show something working. So that's clearly, and that means so somehow I think good ideas are typically R&D programs, European funded R&D programs. You can work there with customers, try to find some industry, some companies. Maybe they are ready for you to build up some demonstrators. So in our case, this was extremely helpful. We were working with Airbus Airbus, we are working with Robert Bosch, we were working with Daimler, and so we were able to build some demonstrators, and this was convincing industry at the same time and enabling, was helping really to have the demonstrators in place. And this is something that we can show then to the investors, and they were much more willing to give us money than by having just a slideshow or a slide presentation. A next step that you should take some consideration, so what is really the core team? So whom can you get on board to start the company? Because you need to have a small core team, you need to write a business plan. That's clearly, as I've said, so this was a big learning for us. So the business plan is really, you shouldn't write let's say, a business plan with the most greatest words where you advertise everything and say how great everything is. It should be really something that you are on your own convinced that you can pull off. So it's really for you that you have a plan how you would, given you get the money, given you get the team together and you can start up, so how you would start really, what are you doing? And this is really for you and not only for the investor. So this is very important. So another aspect that we have been seeing on many on the startups, they were starting up with much too little money. So usually you run into problems, you run into trouble. So in our case, so we were running for 1 year the company. So after 1 year we were able to deliver first prototypes. I can remember this, it was Christmas. We got our first products in and they had some production failure on the board. So we were all sitting with soldiers and had to resolder the product so that we could deliver this year, because it was important for us to deliver in this year because we need to get the money in. If we would deliver next year, then we would have no money and our balance sheet would be horrible. So this was only a minor problem. Then after half a year, the next problem was we were doing 50% of all business with a single customer, and the single customer decided at that point, we had some discussions and they said, okay, at that point, we are only continue to work with you if you give us all your patents and then we'll give you engineering contracts. We were considering this and said, okay, we have not started this company to become an engineering company on an hourly rate. We started this company because we want to build up a technology company. And so we said, no, we don't give you the patents. You can license the patents, we are ready to do that, but we don't sell the patents, we don't give them away to you. Because otherwise we had no asset in the company. And by that time they said, okay, if this is the case, then we pull the trigger on all the contracts. So and this was more than 50% of our revenue. So we are standing there and we're looking for new customers. And usually you don't get the customer like that because it's high tech and you need to work half a year to convince a customer to go with you. And if we wouldn't have had enough money, we would run immediately out of business at that point. So this is really, so I would say you should have enough financial resources to run the company for a half or close to a year. Otherwise, it's really you are in danger that something goes wrong and you run out of money, then you are under pressure to negotiate to get some money in. If you are under pressure, then you get a bad price. So people are playing with you and you are in a terrible situation. So just try to avoid that. Next aspect, so we have been learning this the hard way. We thought when we were starting out the company, oh, it's so great. We have great technology and everybody's going to like this. And then we learned, yeah, it's true, the people, they like the technology, but it doesn't necessarily mean they give you money or they buy something from you. So it's really, you need to have a convincing business case to them. You provide them some advantage for lower cost, more profitability, lighter, cheaper, whatever it is that your customer needs to achieve. And in order to understand this, you need to have in the company the right functions. So you need to have sales and marketing. It's really important if you start a company that you consider what is your market, which niche you are going to start. You are going to start as a very small company, you have very limited resources, and then you really need to pitch at a certain niche, at a certain point, at a certain customer, and try to get this. Because you don't have the resources to go broad. You will be killed immediately if you try to do that. And you can only do this if you understand the market, if you understand the customers, if you understand the dynamics, how big is the market, what business models are established, what are customers willing to pay. So you need to have sales and marketing on board. Second aspect is clearly don't underestimate finance and legal. You need to get finance and legal right. You need to sign contracts, especially if you have patents, then you need somebody who understands this. Usually, we've learned this the hard way. When you go to a big company and they give you a contract for something, then the contract as a standard has a write-up that says all the IP, everything that you provide to the company will then be owned by the company. If you provide them something that's based on your patents, then more or less the patents are going to be grabbed and right away. So if you're a technology company, you need to write contracts that deviate from the usual contracts they give to you, in a sense that say, okay, I can give you adaptions, I can give you higher layers, but the core layer, the technology is staying with us. And this needs hard negotiations, and you need to have legal people who understand this and who can financially set this up. And clearly finance is very important, especially if you start up, you need to manage liquidity, so how much cash do you have, and you need to make sure that you don't run simply out of cash. You need, it's very tough. If you don't have the money, then you're out of business. It's very quick. Another aspect that's some addition that should be considered, it's development and processes. So if you address a research department of a company, they are happy with some demonstrators. They are happy that you show them technology. But the closer you go to the departments that really do the products, then you have a lot of things attached. Then you have certain processes, quality, guidelines, and stuff that needs to be in place. So you need to get people on board who do understand this, or you need to get partners on board who understand that. So for example, I can tell you we had a really hard time, and again it was really for us crucial that we had enough financial resources. We were 3 years in business, and we started a program for jet engine controls, for aerospace jet engine controls, and they are at the highest safety criticality level because they are not stable. A jet engine, they inject fuel, and there are two modes. If you inject too little, then it's going to stall. If you inject a little bit more, then it revs up and revs up until it blows. And if a jet engine blows, it's really massive. Yeah? It takes a complete plane apart. Yeah? So we have been on the first tests, when we won the program on the first test, they did this in the Arizona desert. So they had a concrete house. They were sitting some 100 meters apart, and they were starting up the controller. Everything was simulated. They had the engine and the controller. They were starting up and looking whether it was running at constant speed. Once this was done, so they were building up some confidence that it's really working. Okay, so we won the program. We were really courageous guys to go on this program. The people were highly motivated, and then we had to come up within more than a year to go for a full aerospace certification to prove them that our development process adheres to all the safety standards. So we were a little bit, I would say, naive or optimistic, yeah? And it took us so much money to get that right. So we were doing it. It was just fine, but it took us so many iterations to get everything right. So we get the reviews from the FAA, and they said, no, that's not good. You need to do it this. And just to build up this process know-how, this industry know-how, it's really costly. So either get good partners on board to do it for you, or you have the financial resources to do it, and you really should consider it upfront. Because if you want to get in some product, whatever it is, quality levels, process guidelines, it's considered, yeah, and this goes clearly beyond the good idea that you have in a research program. And some other aspect I can recommend to you, really consider. I think starting up a company is really great, but you need to consider, do you really want to do it? So there's a lot of different things involved. Yeah, you have to fight with the customers. You have some things to get the right people on board. So it's very broad, but I like it very much. So I can only recommend it. But really think: do you want to put in the time? Do you want to put in the hours? Do you want to go through that experience? So some more consideration here. That's my final. Almost the final slide is if I had to pick a single reading on starting up a company, it would be probably Geoffrey Moore, Crossing the Chasm. And he has been looking into many startup companies, so what was ingredients of failure, what was ingredients of success, and he come up with a model that looks in essence like this. It says you have the innovators. So these are the people who wants to get the earliest, the newest, the greatest. They are willing to do this. They are willing to take all the pain that it's working only 80% and it's expensive and it's new, but it's in essence a horrible product. Then you have the early adopters. They expect more, but they are still able to take some pain of some unfinished, incomplete solution. And then he said, this is the scary chasm of the innovators. So you need to gap to this early maturity or to go to mainstream market. And this is really what you need to do, find something, and in his terminology he called them beachheads. So you have this island where you need to have your landing troops that bridge over the chasm to go to the beachheads. And to find, I was referring to this vertical. So a very precise, find something where you could provide a value to your customer. You need to find this and then really hit this to find some beachhead over there to get into this maturity market. Because the maturity market, they want to have a solution that's plug and play, that's easy, that's convenient. They don't want to hear too much about new technology. So it's nice if you say it's new technology, but in essence they don't care. They want to have some advantage, being faster, being cheaper, being more powerful, lighter, whatever it is. So they want to have the advantage, and they don't ask you, this is built on time-triggered or deterministic or whatever it is. It's nice for them, but it's only sugar. So if you start up a company, you're usually there. This is something you're usually going to manage, and then you need to bridge over there.
Is Audi to the left or to the right?
Which one?
Audi to the left or to the right?
Well, so Audi is, they are here, I would say. Yeah, they are clearly the majority.
Autonomous driving part.
Well, you could argue autonomous driving, but in reality, I think the car industry is extremely conservative. Yeah? If you look today, you have automated cruise control. So you have radar-based controlling of longitudinal traffic. This is on the market for now, I think, close to 10 years.
Yeah, but it cannot be at the majority because they're not selling it yet.
It's sold today.
Autonomous driving?
No. So I would say the step between what you can get today in a car, if you buy a Mercedes S-Class, in a Mercedes S-Class you get an automation function that keeps the distance to the guy in front of you. Radar and camera based. So that's on the market. It keeps keeps the lane, and the only difference is to the next step is that Mercedes says you need to watch the car all the time, because we don't give you any guarantees that it's working fine, but the function is already there. And so you could argue it's a big step to say, okay, you can look some other direction, yeah? That's clearly it is a big step, but if you take it from the perspective that they have the function already in the car, I would say the step is not so big. At least that's my take, yeah.
But they're not anywhere on this chart, right? Because they didn't tell you.
Excuse me, I didn't get it.
The autonomous driving system is not sold yet, so it's not on the chart yet. I mean, you're hedging the question, so I'm trying to figure out. You're just comparing all the parts that are available in the car today.
Yeah,
But the vision that you introduced earlier
yeah.
is not on the market, right?
Yeah, clearly it's not on the market, yeah. But I would say,
Or are you saying they don't have to go through this chart because they're a big company, and so they already put their things into place so that when it's on the market, it's going to be a hit?
so let me put it that way, maybe it was taken wrong. I would say the company Audi as a whole is standing here. So they have some things where they are early, and they have some things where they are late. It's an innovation. You could maybe argue they are maybe more here on this side, but it's car companies. There are so many aspects. They are not early on everything, and they are maybe early on many things, but not on everything. Yeah. But they are clearly a mainstream company that is not taking risks, that is not taking very, very radical steps. What this chart in essence says, if you're building a new company and you come up with a new solution, then you have to find customers out of this domain who pick up your solution. Because if you're only staying there, then you will always work with some research departments who have limited money, so you can work in some research programs. You're not going to grow a company. If you stay here, you can stay as a nice research boutique or R&D company or incubator or whatever, but you are going to stay small. If you want to grow the company, you need to bridge over. That is the idea of this chart. It's not about it's about the evolution of companies and which markets you can address.
I think that the way Moore meant it is also that you don't categorize companies really on this, but it could also really describe just the way you cooperate with the company, right? I mean, you can have an early adopter in the R&D department of Audi,
Yeah.
and he loves your idea, and he actually buys your product, but for R&D purposes, right? And then this guy could become a beachhead,
Yeah.
in his terminology, for getting into Audi as a real product.
Yeah.
You know? So I think that's
Yeah.
good along as well.
So this is more from the perspective, you're a startup company. So where can you land? And usually, when you're very early stage, you can land here with very innovative R&D research people. And what this really says, if you want to be commercially successful, you need to bridge over to those guys. That's more or less Moore's idea. Okay, so finally I would like to conclude with a statement that says, so I think creating a company, it's a lot of joy. It's clearly some pain as well, but it's very rewarding, and I think it's personally very rewarding, and I think it's very important as a second aspect for society, because I think our society needs to live on new ideas and new companies, because some old ones are dying and some new ones need to come up. So this is let's say, the innovation or evolution cycle, and so I think this is very important. So thank you very much.
I'm wondering if you consider this set of companies where the business idea is based on research, would you say that typically the business idea comes to the researchers or the researchers come up with the business idea? Because I think typically for a researcher, it's not trivial to figure out that what he is doing has some business potential because it requires different mindsets to see that, right? So the question is, do people come to researchers typically and say, oh, you could make out a business from that? Or do typically researchers for such companies came up with the business idea?
It's clearly a difficult question, but my feeling it's so let me back up. I have two approaches to this. So one approach is I think what here in Europe, at least what we faced always as a struggle was that big companies were quite conservative in terms of taking up new ideas. So new technologies that we brought out, we always had our first customers in the US. In US it was much more accepted. If you have a good idea, if you have a good team, then it's like, so it's good people, it's good technology, so why not? They can do it. And here it was always the approach, oh, it's a small team, it's new, so if it's really a great idea, why doesn't Siemens or why doesn't Bosch has already had this idea? And will they be there tomorrow? So I don't know, should we really invest? And then they are gone, and yeah, so this mentality. So I think this is a little bit changing, yeah. But personally, I have not seen a lot of drive out of big companies to really doing new things and doing startups. So I've seen it was always people who are coming out of research, people who are leaving big companies and said, okay, I'm no longer going to stand all this bureaucracy and all these walls and all this conservatism and we cannot do new products, we don't get budget for new things, so I'm not going to stand this, I'm doing my own thing. This is what I've been seeing. But really that a big company goes and say, okay, you have great ideas, so let's pick this up. I've seen this very seldomly. Usually there's nobody there who has the authority to do it, and yeah. So maybe just recently we see some change of mind that big companies, they have some investment funds, some small investment funds to invest, but it takes the individual really who says, okay, I have some idea, I want to do something. But it's clearly, I understand the problem, so usually if you do research, it doesn't mean you already understand what industry is doing and what problem you can solve. But one of the approaches is to do some funded research program. Maybe you can interest some industry to do a joint research.
So as a founder or co-founder, do you have to invest some private money into the company, or do you have to guarantee with your private property for some bank loans you're getting?
So when we started the company, we put in, so we had a first round of funding. This was family, friends and fools. So we put in some of our own money into the company. We had some relatives, some friends who believed that this could be something, and they put in some money, and we all told them, if you give us money, you must be aware it could be gone. It could be simply gone, yeah? So we'll try our best, but it could be gone. And then when we started this was some of the core funding, and then we went to there is a lot of institutions in Austria, so I think we have like INITS and others, so there's a lot of good stuff they can support you in getting some money. And then really make sure that you don't take personal liabilities. So you put in some of your own skin, you put this into in the company, this is a certain amount of money, but please don't put in everything. Banks, some of the there are some institutions, some investors, some banks, they ask you that you give unlimited liability. Don't do this. See, I've put in a part of my money, a part of my wealth, but that's the limit. I'm not going beyond this. Make clear for you how much you can do. You should have some skin in the company, that's clear, but don't put in everything. And make this really clear. We had this with some of the investments. It was a big fight with them, and we said, we are not willing to do this. We've put in some money of our own that we've earned, and we are not going to give you unlimited liability for everything. We simply don't do this. I'm not willing to do this, because if you fail, and there's a good chance that you fail, then it should be okay for you. You should be able to go on, have a new job, do something different, and don't have for the rest of your life an obligation. That's ridiculous. That's not what a startup is about. Make this clear and you can get it.
If you consider the likelihood for a company to spin off from a university in the US or in Europe, or say in Austria, then I think we can agree that the likelihood in the US is much higher than here. And there are different reasons. And one reason for sure is I think that in the US there is something like a startup culture, and there's no such thing, or basically no such thing in Austria. But I'm wondering whether there are more reasons, like for instance different situations at the universities and so on. So do you have an opinion on other reasons?
So I think let's say the startup culture is clearly a very big motivation. So in the US or in other areas, let's say it's cool to be starting up. It's cool to be an entrepreneur, to start up company. That's considered cool. Yeah. So maybe in Austria it's considered partially cool. So different opinions on that. And clearly another aspect is there's much more venture capital in the US. That's clearly an aspect. So there is a lot of money there, and people, especially the current financial situation, there's so much money. So all the central banks, they are flooding with money at low interest rates. So it's very attractive to loan money and find some startup that seems doable. Actually, I can tell you, even here in Austria, we see many startups. So it's not that they aren't there. So we have a lot in biotech. We have a lot of startups. Yeah. So I think clearly you can say, okay, you have elite universities like Caltech and MIT and Stanford, whatever. We don't have elite universities here at the same level or same breadth that the US have. We don't have that, but still I think on certain punctual levels or certain points we have very strong research here in Austria or in Europe. So I think it's really more a matter how to leverage this. There's always this suspicion out that Austria, we love mediocrity. And this might be true to some extent, but I think we have really a lot of top-level research. We have a lot of really very strong innovative companies. So there's a lot of really, I would say, very strong things, and I think it must be more aware that this is possible and you can do it. So it's, I think it should be more public. Yeah, I share this very much.
Let me just say one final thing, actually, and thanks very much that you brought this graph here, because I think what we are doing at IST, obviously, and you have seen this with the beginning series of events here, is really to bring together these two worlds, right, as you asked about before as well, business and research and academic worlds. And we are obviously, and as you said, really starting, I mean, this initiative is even younger than IST, right? So for this, we are really somewhere here, I guess. And I really hope that TTTech will be one of the beachheads that allows us to go to here as well, right, in this cooperation. So thanks very much, Stefan. Thank you.
Okay, thank you very much for having me here.
you.